Welcome to this lecture, which is about conditional statements. This learning target is LO4. Don't forget to put your name, your period, and the date. This lecture was done on Monday, August 13th, or Tuesday, August 14th. A conditional statement is also called an if-then statement. It's a statement that requires a condition in order to have the result. So, if I come to class every day, then I will get an A. The only way to get an A in that statement is to come to class. There's a condition. So there's two parts of the statement. There's the if part, right, which is known as the hypothesis, or we consider that to be the conditions, and there's the then part. This is the conclusion, or the result. Alright, so if part and then part. Alright, the symbol for a conditional statement is an arrow. So whenever you see that arrow, you should know that you are working with a conditional statement. So this right here would represent if A, then B. Now, a truth value, remember, is when you're trying to decide between true, false, or open. Those are always your three choices. Okay. So I'm going to go through and I'm going to talk about each possible situation. So when you make this truth table, right, it has three columns. Now the point of a truth table is to help you figure out which one your statement is. Alright, so the first column of the truth table is for your first statement, A. The second column, your second statement, B. And the third column is for if A, then B. Okay? The first situation would be if both are true. So T stands for true. So if both statements are true, so take our example, if you come to class, then you get an A, right? You show up to class every day. Now the first statement is true, okay? And at the end of the semester, you get an A. So the second statement is true. So if both are true, overall, the whole statement will be true. It makes sense, right? You did the first thing, the end happened, therefore the whole thing is true. Now the second situation is false, false. In this case, you have the opposite thing happening. You never come to class. So now the first statement is false. So in the end, you don't get an A. The second statement is false, right? No class, no A. But the statement isn't wrong. It still makes sense that if you didn't come to class, you wouldn't get an A. So the statement as a whole is true because it's correct, right? Neither happened, so the result didn't happen. The tricky thing is the mixes. So you have false, true, and true, false. False, true, I usually give the example of you're working on a problem and you do it completely different than your teacher. But in the end, you get the correct answer. So even though you did it wrong, you still got the right answer. So, I mean, your answer's not wrong because you did it different. It's still correct, right? So this is still a true statement, right? I mean, if you take our example, you never come to class, but you still get an A, you're good. You got an A even though you didn't come to class. The last one is the opposite, right? You come to class every single day, but the end of the semester happens and you don't get an A. you're going to be upset. That's not okay. That's not a true statement. So this is the only way to be false. Right? Because if you're going to come to class, your teacher promised you that you were going to get an A. So this is kind of like lying to someone, right? So you don't want to lie to someone. You don't want to have a false statement. So you cannot go true and then false. So these are the 4 situations. Notice only one of them you can end up false. Otherwise, you end up true. Okay? All right, so let's do this example. Okay, now the first thing it asked me to do is tell me what this represents. Okay, so in order to do that, what they're talking about is writing the statement. So first, you always put the word if statement A square is a quadrilateral, then statement B, a square has 5 sides. So notice that statement B is right here, and statement A is right here. And then you always have these words, if and then. Okay, it's not a conditional statement unless you have the words if and then. Okay, so that's as simple as that. That's how you write a conditional statement. Now in the directions, the second part says determine the truth value with justification. So whenever they're asking for justification, they're asking you to make a truth table. Okay, now before you make a truth table, you need to determine whether your statements are true or false, because that's going to really help you when you're making your table. So a square is a quadrilateral. Now, if you don't know what a quadrilateral it is, you could have looked it up, but that means that it has 4 sides. A square has 4 sides, so this statement is true, right? And if you don't believe yourself or whoever's talking to you, you could just draw a square and notice that it has 1, 2, 3, 4 sides. Okay? Then the second one says a square has 5 sides. Well, we just talked about that it has 4 sides. So this is false. And since I already drew a square, this can be my counterexample. Now, doing this is extremely important, especially on your test, because this shows me your thinking process, right? So even if you said this was false, but you gave a good example, I would still give you points, okay? Now you're ready for our truth table. So truth tables have 3 columns, one for A, that's our first statement, one for B, our second statement, and if A, then B. Okay? Now we decided that statement A was true, so I'm going to put a T, and statement B was false. Okay? And if I look up here, if I start true, right, like my hypothesis is true, but my conclusion is false, then the whole statement would be false. So this is a false statement. And there you go. That is a typical problem that you will see on the test. All right, now down here, okay, this is a little bit more challenging problem. This is called an error analysis problem. All right? And what they want you to do is they want you to find the mistakes. Now, I'll give you a hint. There are 3 of them, okay? The first thing to notice in these problems is that over here, this is the original problem. This is what they asked Margot to do. Let's label that, okay? So they want to know if C then D is true or false. So we need to justify. So if I was doing this problem, right, then I would start by writing my statement, right? So when you're doing error analysis problems, that's a good strategy to just go through the problem as if you were working on it And that would be a good way to find your mistakes, okay? So the statement says if C, then D. So you would need the word if first. Okay, good. She did that right. And then write statement C if X is an odd number, right? So this is statement C. Here's statement C. Then you need the word then. So far, so good. And then you need this statement. However, if you look, this does not say the same thing, right? So one of the mistakes she made was here, number 3. Okay, so I'm going to label that. Number 3. She wrote the conditional statement incorrectly, right? She did not use statement D. Okay? So that's her first mistake, because you can't just change what the statement is. You need to use these two, all right? And then what I would do is I would, just like I did up here, I would decide whether they're true or false. So Margot said that C is open because X is a variable. Well, that makes sense, right? We're not sure what X is, right? Some X's are odd numbers, but some are not. Okay, good. Check. She did that part right. X squared is a positive number. Well, before I read hers, let's try some examples, right? So you could use, let's see, if X is positive 2, right, then X squared would be 2 squared, which is 4, right? That's positive. Now, if you use a negative number, negative 2, X squared would be negative 2 squared, which is also 4. Positive. So even though one time I used a positive number and one time I used a negative number, they're both positive, right? So, okay, so she thought it was true just like us, good, because if X is positive, then X squared is positive. If X is negative, then X squared is, wait a minute, that's not what we decided. We decided that it was supposed to say positive. So even though she got the correct truth value, she wrote the justification incorrectly. So number 4, that's number 4, okay? So she did this one right. We're going to cross this out because she did that correctly. Okay, and there's definitely no mistakes, right? All right, so now let's fill out our truth table, right? She set it up, right? Column for C, column for D, column for if C, then D. C is open, so that's why she put a T and an F, because whenever it's open, you want to take into account both situations. D is true. Now she put 2 T's, probably so that she has 2 rows, a T to go with T and a T to go with the F. And then you have to essentially solve this and figure out what kind of truth values you got. So true, true will always give you true. False, true should give you true. So this should not be an F. This should be a T. So there's her last mistake. This is mistake number 5, right? Is that false, true will give you true. Because remember, that's like doing the problem a different way, but getting the right answer. So this is not an open statement. This would be a true statement, because in the end, we ended up with 2 truths. Okay? So that's the we do. That's an error analysis problem. All right, the last one on the notes, okay, is another example just like the I do. Okay? I'm going to give you some time to process it, and then I'm going to show you the answer. I don't know if that was enough time. If you're not ready for the answer, what I would do is pause the video and then continue, all right? You want to write the statement first. So if E, then F. If the number 11 is prime, then X squared is always even. That's your conditional statement, all right? So then the next step is to determine whether they're true, false, or open, okay? The number